All right. So our next print-in-place design is going to be a ball and socket joint, and these exist all over the place. I just pulled up a couple of examples here in Google. So the most prominent example you'll see will be in the human hip. We have a ball and socket joint, so the ball will be lined with, I think it's lined with cartilage. It's been a long time since I took an anatomy class, and then it'll fit into a socket there, and it allows your hip bone to move in all kinds of ways. So like hurdlers can really, move their leg over and up to get over the hurdles. It allows us to walk. It allows us to do stretches, move sideways, kinds of stuff that we get out of a ball and socket joint. You can also see them. Here's an example, and I don't know that I found like the best example of an image. Oh, here we go. This is probably the better one. So here is a ball, this is a socket, and this is also a fitting that fits on the drain. So this would be like the underside of your bathroom sink if you have one of those little pull knobs that you pull to stop the water and push, and sometimes they don't work that well. But what this does is this will screw on and make a watertight seal, but it will also have a little ball and socket for this to move up and down. You pull the lever attaches way out here, the arm, in the back of your sink faucet. And then as you pull that up, it will pull this part up. This end of the socket moves down and it closes your drain. So you'll see those there. This will not be a print-in-place version like what we have, but it's an example of the type of joint. And then I couldn't find, every time I say I can't find one, there I see one. Good old Reddit to the rescue. So if you have a stick shift or been around a stick shift car, I know they're a little less common now than they used to be, but they're still out there. They operate as a ball and socket. So the ball down here will fit into the socket and it will kind of manipulate what's underneath there to get your transmission into gear. And then, it's covered up by all this stuff here. And then there's a shift knob. Don't be confused. That's not a ball and socket joint. Although, as you move your hand on top of it, I suppose technically you make yourself a little bit of a ball and socket situation with that too. So, hooray. Let's go crazy with that. All right. So what you should do is open up your template, and we're going to do something new today. This actually is going to be a really easy thing to design, in my opinion. So we're going to basically draw in a lot different way than we do normally, so that we can create this shape. So what I'm going to do is start with my line tool, and I'm going to start at 0, 0, 0. And I lied here a little bit. I can use that line tool. Let me go ahead and save as, and let's call this ball and socket. Okay. Now I'm going to 0, 0, 0 with my line tool. You can draw this in 2D if you'd like to. I'm going to go over, I'm looking at one in front of me without measuring it. Let's call it an inch, because I think basically what we're going to do is draw this. I messed up. I'm going to draw this in half, and you'll see why here in just a minute. And so maybe I'll go up 1 inch too. Keep things pretty simple for us here. Okay. And I'll just go ahead and make this box. We'll go over here 1 inch, and we'll go down and close that shape. Okay. Now what I'm going to do is create a circle. And this circle, I'm going to start here. I am going to move it, but I'm just going to go out here. I'm going to go a little bit wider than that 1 inch. Let's go 1.125. So 1 1/8. It'll give us a 2 inch and a quarter circle. And then what I will do is move that. So I'll choose my circle right there. I'm going to grab it there and just move it up to the corner here. Okay. I can go ahead and trim. So I'll choose my scissors up there, or type T for trim. Cut those out. I am going to leave the circle intact for right now, but I'm going to come back and bisect this. I'm going to start down here where this intersection is with a line. I'm going to go straight up to the very top and bisect. I'm going to divide it evenly in half. So far, so good. I think I'll leave the circle for now. I will come back and kind of take care of it a little bit more here in just a second. And then I'm going to go ahead and from the top of that, let's go up, I don't know, let's go up 1/4 inch. Let's go up 3/8, 0.375. We'll go over 0.375 and we'll go down. And I'm going to leave my ortho on. I'm turning my snapping off. A lot of times it's hard to get it to attach to a circle. So if you just go like that, past, and then trim it, seems to be the easiest way to operate there. All right, now we've been talking a little bit about offsets. So I am going to offset this, and I'm going to make it so that it's an 1/8 inch thick wall. That should be plenty. So I'm going to type, I hit offset, I'm going to type 0.125. I'm going to click on my circle because the circle needs some thickness. So this will be like the outer shell of the circle. And then while I'm at it, I was a little early with this, but that's okay. I can still use it. Now what I'm going to do is offset again, but I'm going to offset 0.02 because that's going to give us, if you remember from the past, it'll give us a little better clearance. It'll allow this to move a little more freely, and more importantly, it'll allow this to print and give us a more likely opportunity to break this loose so that it actually does move without breaking the piece. All right, I'm just going to pause real quick. All right, I'm back to it. Okay, so let's go ahead. I went to offset. Now I'm 0.02. I need to hit enter, and I'm going to go and offset that and click. This is going to be the actual ball that I'm going to use. And then the next thing that I'm going to do is I'm going to take a line, and anywhere above the halfway point. So let me turn this back on so I get quadrant. So I can't go at the quadrant. If I do, technically it'll be a ball and socket joint, but it could fall apart at any time. It could just, there's nothing holding it in. So we need to go past halfway. So I am going to turn this back off, but leave my ortho on. And it's really up to you. Find that halfway and go up a little bit, and then just make a horizontal line like so. And then I'm going to trim it to everywhere except in between here. Like that. Okay, now what I'm going to do is go and trim the things I don't want. So I don't want this line, I don't want this line, and I don't want this line or this line. I don't want this one either. Really anything on that side. Almost looks like I'm making like a bobber or something. All right, so now I've got to do a little bit more. I'm going to trim this one right here. Okay, and then I can go ahead and trim this. Okay, that's good. Now I told you I messed up when I made this line, and I did. Wasn't lying to you. I'm going to go ahead and, let's see, I actually wanted ortho on. I turned it off. I wanted to turn the snapping off, but that's okay. All right, so I'll trim that one. I don't know what it is with circles, but I guess it's just it doesn't know where you want to intersect with it. So, okay. So now I go back to trim, and I can cut this area out. Okay, now I'm actually almost done. This is going to use a thing called Revolve. And, everyone's always, oh, the world doesn't revolve around you. Well, okay, fine. But the world will revolve. This will revolve. I don't know what to do with the words I started to say. I need to make sure I'm in 3D for this next step. So I'll go there. And I'm going to region this area in this area. But to make my life a little bit easier, I'm going to go to X-ray. I might just go straight to realistic. And now I'm going to region. And I'm going to region this section. Oh, it didn't go. Why didn't you region? So here, here. Oh, that's why, right there. This goes too long. So I actually need to break that right there. I'll check on that when I get there. So now let's try that again. There we go. And now let's see what happens when I go there. There was that. There was that. I think we might be able to work with that. So I'll region, and now I'm going to region this separately. Good. Okay. So we're kind of holding on to it there, right? We got this little thing. It's going past halfway. That part's important. And now we can go to our 3D tools. And I thought I went there, but it didn't take. So I must not have. So I'm in my 3D tools. I'm going to go to solid. Okay. And then I'm going to look for this thing, Revolve. And if I hover over it, it says it creates a 3D solid or surface by sweeping a 2D or 3D curve around an axis. This is a really good way to make round shapes. If you want to make some sort of a vase or something like that, this would be a really good way to do that. If you were making a cup, that would work too. So I click Revolve, and then I'm going to select the object. And then I have to choose the axis. So what I want to do is choose the very top corner. And then anywhere straight down the y-axis is fine. And then if you look, it will kind of fill everything in. It asks you how many degrees. You don't have to go 360, but for this you do. So I'm just going to hit enter because that's the default. A lot of times you revolve something, it's going the whole way. So if I change my angles, I don't know why it's not going when I click. And then when I do click, it's not showing a nice animated thing, but it's probably the graphics card on this. Now I'm going to do this one more time. So I'm going to go to Revolve again, and I'm going to do it with the base piece. I'll choose that, and then I'll go to 0, 0, and I could just go right up here. You could go up to the middle, but I'm going to go right there. 360 degrees is fine. Hit enter. There we go. I've got a ball and socket joint. Hooray. I can do it. Now, do we have to have a wall this thick? Maybe not, but that's okay. All right. Now, because we're dealing with round stuff, let's go to Facet Res, turn it to 10. We're ready to export. I didn't select it ahead of time, so it's going to ask me to choose watertight meshes. Choose everything. Hit enter. It will have exported. Let's go find it. There it is. Let's open it in PrusaSlicer. Pause here, blow my nose. Okay, I think I hit record again. Let's double check. Yeah, I think so. So I'm going to PrusaSlicer. We did make this in inches, so let's choose yes. And it's going to load this here. Now, normally, under most circumstances, I would print this on this surface. But because of the way I know 3D printers work, I'll explain in a little while. I'm actually going to start it on this surface, which should make you cringe a little bit. Like, why is he doing that? He's told us so many times, don't do that. And I'll show you why in just a minute. Infill's fine, 15%. The print settings there generally are going to be fine. We want to turn supports on everywhere. We've learned from other 3D prints, probably if we're doing these in the same order that I'm recording them, that it's not going to fill in that 0.02 gap with supports anyway. So that should be fine. We can get picky with them if we want to, and we should probably just make sure they're going to be at 0.2 detachable, so 0.2 of a millimeter. And, I like gyroid. I don't know why. I think it's fun to look at while it prints. Maybe that's why. But I swear at one point I read that was strong. Okay. Hit slice now. Okay, now let's get into why I did it this way. And here's why. So all these different colors, the key is over here for why they are the color they're colored. And so what I'm looking for here is where it starts to print the ball versus the socket. Okay, so right here is the inside of the socket, right here is the outside of the ball. When I get up to this area, it will print the top of the ball much nicer this way, and it's going to print the underside of the ball less nicely this way. But with supports, it'll be functional, even if it's not quite as nice. Then the inside of the socket, it will print a lot nicer, being as they're seeing as though it can build off of the previous layers. It's a pretty steep angle, but it can still do what it needs to do for the most part. So when we go to break this loose, usually we can just twist it and it'll come loose. Now I can't promise yours won't break, but it should be good. And so that's our printed place ball and socket joint. Do not scale this. You see the cost here is $1.55. I'm willing to spend that for your knowledge, the knowledge that you gain. So don't scale it. If you scale it, you lose that 0.02. I did that when I first made this, and it was kind of a foolish move. So don't be a fool. And other than that, that's your ball and socket joint.